How's everyone doing today? Do we have people? I told you I was going to be back. I told you I was going to be back in the morning. Guess what? I'm back in the morning. Wait right here. I'll be back in the morning. We'll listen to that song. That'll be how we start off our stream. Got a mate. Perfect for the morning. Hello, people. I was watching some Jersey Shore family vacation last night. It was pretty awkward. Good morning, Kempfic. Pretty good. We got some pull requests. So let's shout those people out. Shout out Quilford and Faham for submitting some pull requests, which is great. Love to see you guys contributing. TwitchSlam, of course, is MIT licensed, so anything you'd like to add, any bugs you'd like to fix, we certainly welcome it. I think we now have Linux support. She love me, you know that one day I'll be over to see. Making my money and smoking my weed. I think it's funny, she opened up to me, get comfortable with me. Once I got it coming, I love her, she love me. I know that I'm nothing like someone a family want me to be. If I find a way, would you walk it with me? Look at my face while you're talking to me, cause we only have one conversation a week. Can I get one conversation at least? Shout out to everyone making my beats. You helping me preach, the music's the only thing keeping the peace when I'm falling to pieces. All of the stars have a reason to shine, a reason like mine, and I'm falling to pieces. We'll go back to talking in a minute. I don't know what's wrong with the shit, bro. Alright, let's go back to working. So what did I say we're going to write today? We're going to write the tests, right? So, if you go here, it starts up and it starts slamming. Now, I don't know if these poses are actually in the right place, but fortunately, we have ground truth for this. It's in videos, ground truth, Freiberg, XYZ. So let's just make that another parameter you pass in. Well, if I'm going to do anything, we don't write the code. So, annoying, because look at the top here. Like, this doesn't start at 0, 0. It starts at some weird coordinate frames. We're gonna have to deal with that. And we're gonna have to deal with the fact that, oh man, alright, let's go. Have we got that much space? Is that good? No, I'm smoking weed this morning. It is a work day. Well, let's go. We'll pass in the actual pose to process frame. That's what we'll do.
Happy Wednesday. Okay. Do a split. Filter. Wants to start with that. We'll do a strip in there. Map float. There's probably like a one-liner to read this. Yeah, we have work to do. We'll get there. I want to map float across x dot split that for x and t and the array. Just say that. Sorry about anybody who liked SSA format. And this is of course wrong. That's right. Valid syntax. What do I need? I need a colon there. Missing parentheses. Python 3. Never get it right. Map object. No. That doesn't actually run. List comp lambda. What? Map lambda x. Map float. Fine. I don't know why. I guess I won't use a list comprehension. Map object. No, I want it to run map. Oh, is this some Python 3 bullshit that I don't know? Map object. Does this do like lazy evaluation or something? Does Python 3 lazily evaluate maps or something? Oh, I filtered that. Oh. Oops. Alright, cool. Now I can empty array that. Yeah, we gotta do work before we do work, you know? It's like pre-gaming. Okay, so those are the quaternions. Now we're going to need to write some code to go from quaternions to matrices. Well, yeah, let's do that. Let's put it in helpers. Quaternion to rotation matrix. There we go. There's got to be a library that does this. Pi quaternion. That looks shitty. Is it like a normal? Rotation from matrix, translation from matrix, Euler matrix, quaternion, shit. So quaternion is another way to represent. Oh, this looks pretty good. There we go. Perfect. Just copy that. What's the license on this? Does it have a license? It's kind of, yeah, it's kind of good enough. Assuming. Let's see what these things do. If n is less than underscore EPS, epsilon for testing whether a number is close to 0. Well, that doesn't seem important. Oh, and this isn't vectorized. We have to vectorize this. I'm doing pretty well. Okay. We definitely don't need to make a stupid copy. NumPy outer. That's interesting. Why are they doing math.square root and not NumPy square root? Wait, what? And this is doing too much, man. Vectorize function NumPy. I'm going to vectorize this, you know what I'm saying? Vectorize quaternion matrix. I'm not excluding any of them. Seems right. Capital R because it's a matrix. From helpers, import quaternion matrix without the underscore. Let's see, is that going to work? Local variable Q, reference before assignment. Oh. What? Where's the shit that I copied? No, well that's crap. Just change that to Q. Index 2 is out of bounds for access with size 1. Of course, yeah, no, I gotta put my parentheses. Oh, those are very important. Okay, well, it seems to do nothing. Did I not use vectorize correctly? It seems like it works. NP vectorize. Define a function which takes a nested sequence of returns a single or a tuple. I don't know about this. Alright, well, let's just write it the stupid way for now. And then maybe somebody can fix this later on a pull request. Love when you all write pull requests. np.zeros. QQ that shapes up on 3, 4. QQ shape 0. Oh, look at the sky tonight. Oh, the stars have a reason. A reason to shine, a reason like mine, falling to pieces. Alright. To write this. Not dumb. Right, you see what I just wrote. I should feel ashamed for what I wrote. It was terrible. Are there tabs? Tabs are the bane of my existence. I hate tabs. Okay, cool. Now that works. I don't know why vectorize doesn't work. Somebody who actually like knows things can probably make that work. But that's some ugly ass code right there, so, you know. I'm thinking about the language, you know, the kind of languages that like, and pose.rt is also not a vectorized thing. It should be. Well, we'll just do it. GT pose equals np zeros. GT.shapes of 0. GT 4 4. GT.pose subcolon 33 equals 1.0. GT.pose sub. I'm kind of copying pose.rt here. It's kind of shitty of me. Missing call and parentheses. Oh, wow. Clearly, it's important that I do this. Where's the... Oh, God. Okay. So, a few things. I think what we want to do is say np linalg in gt pose sub 0 np.mapmul that by gt pose. Is that gonna work? Move to the first frame to the origin. Is that gonna work? Work maybe? Yeah, it looks pretty good. Cool. So theoretically, those should be poses. The thing is, like, I don't know if that's actually correct with the rotations. I'm not sure, like, I've always been kind of confused about which is applied first. Is the rotation applied first, or is the translation applied first? Yeah, this looks wrong. Let's look in the actual ground truth and see what it is. So we know that the first thing it does is moves on the z-axis. So, yeah, that looks like it's just pretty much moving on the z. Why is that showing a bit of movement on the y? That doesn't seem right. So therefore, what we might want to do is we might want to unapply the rotation separately. We might want to do it like this. Put it back kind of to what we had. So if it is the other way, then we just want to do this. It's still moving a lot on the x-axis, but at least it's not moving on the y-axis. Let's try this. It's still moving on the x-axis. Take a look. So these are the, look at that movement. I'm not sure that's real, right? Because like when you look at it actually slam, it looks like it only moves on that axis. So let's try this. Maybe we have to unapply the rotation from the translation. Well, let's try that first. See, like the order matters, right? Shapes are not aligned. Bro, align my shapes, bro. Transpose. There we go. Alright, now it's moving in the y-axis. This is worse. It's like I don't know what to do, right? Try that first. Like we would expect movement really only on the z-axis. That's identical. Which that doesn't seem like it should be identical. That's identical to that. Which is different from this, but we don't unrotate the translation. But you see how this is like messed up like this? Hashtag anti-hype, bros. Hype's bad for you. For the first 100 frames, it just comes forward in the Z. Well, okay, you know, I might just be wrong about this. Let's let's print the pose. F is not defined. F1. So there's the pose. Yeah, so notice how we're moving almost exclusively in the z-axis. Remember, everything about this is up to SLAM. It's up to scale, sorry. It says we're moving forward in the z-axis, which is actually wrong. And that's because what we really want to do is we want to invert the pose here. But yeah, so it's moving almost exclusively in the z-axis. So in order, whatever this ground truth is, it better be exclusively in the z-axis. Freiburg XYZ, I got the right thing. Okay, that's not happening. Let's read the website. Maybe there's some information about it. Yeah, okay, that's not it. Freiburg dataset. How did they get the ground truth? Where does the ground truth come from? Where does ground truth come from? More info. The connect was pointed at a tip. Oh, it's a connect. The sequence contains only translational motion, as it is very simple. Ground truth trajectory. So that's what we did. Yeah, here we go. So clearly we have to rotate it back. Like, let's just play with the rotation first. If we get that to be correct. Or sorry, the translation first. Let's get that to be correct. Like, we should be able to do this without dealing with the rotation. Okay, so that's clearly wrong. And we can even, like, sample a little more. Like, it is moving along this axis, but first off, there's a huge offset. You coding up AI to save me, bro? That's I think what I'm doing. It's not right. Okay, what if we switch the order of those? Does that matter? How does that not matter? Like, it's literally the same. But how? That doesn't make sense. Oh, I'm still printing the shape of something stupid, aren't I? Yeah, there we go, die. Okay. So you guys see the problem? This is X, Y, and Z. And the movement, according to my experiments, should be almost exclusively in the Z-axis. But it's not. I didn't read it wrong, right? T-X, T-Y, T-Z, and I did from 0 to 4, that's right. And I did from 4 onward, and that's the quaternion of rotation. I mean, it's possible that this is wrong. Or, ooh, I know what's possible. Oh, maybe you don't actually want to invert this. Maybe, they encode it weirdly. Let's try that. Okay, well, that's showing no motion in the Z-axis, which is interesting, because that's the only place I thought we'd have motion. That's worse. Great. See if they talk more about how the pose is. Ooh, well, let's check if my intrinsic parameters correct. Yeah, that's half. That's fine. Compute the intrinsic parameters. Oh. That's normalizing the stuff. Ah, here we go. Okay. Gives the position of the optical center of the color camera with respect to the world origin as defined by the... it's a Leopold mechanical... I heard this is what a lot of live stream coding devolves into. It devolves into kind of bullshit where people talk about keyboards and setups and stuff. Okay. Well, first off, are the timestamps vaguely sorted? Let's make sure I'm not doing anything stupid there. Yeah, they're vaguely sorted. Okay. Gives the orientation of the optical center of the color camera in form of a unit quaternion with respect to the world origin as defined by the motion capture system. Okay, so I think we're first going to want to rotate the world. We're going to want to unapply this rotation. So in algebras, right? Wait, this isn't necessarily correct. Orientation with respect to the motion capture system. So we want to move everything into the orientation of the camera. God, this stuff is really hard. Okay, so here's the center of the motion capture system. Here's the camera facing this way, right? So if what we want to do is move things into the perspective of the camera, how do we do it? Basically, this is the new origin. So we can certainly subtract that. Or here. But we're still rotated like this. So now I think we rotate. That isn't right. Oh, maybe we want to rotate and then rotate back. Let's just try that. wrong, but no. Okay, we shouldn't just be trying things. I'm so bad about this. My map models aren't wrong, right? GGR equals quaternion matrix. Yeah, it's fine. I didn't like typo this, right? Wait a second. Is that even a rotation matrix? That's a weird-ass rotation matrix. Is that function broken? I really hope that function's not broken. np dot qq q times np squared. Let's just double check that. Quaternion to rotation matrix. Yeah, I'm aware. I'm aware. Well, you show me a better way to do it. Like, once I know the answer, it might be helpful, but... Okay. It's a unit quaternion. Let's try just multiplying this. Well, let's just see if that's... That should be 1, right? It's not 1. It's n. N is 1. Do we really want to multiply by that shit? I don't know. There's a way to check if something's a valid rotation matrix. I think we could do SVD on it. Well, yeah, okay, so I'm trying. Okay, so the middles are 1, so that's a good, these eigenvalues are 1. So if the eigenvalues are 1, I think they're called eigenvalues, then it's a real rotation matrix. Okay, so that seems okay. So here's the camera, and here's like 2 poses, right? So here's pose of camera 0, here's pose of camera 1. So we want to rotate everything into this coordinate frame. This rotation is defined with respect to this. Okay, it looks like they all change. So that makes sense. So if I subtract that out, it's like I'm moving this to here. Now I want to go like... I just want to unapply the rotation, right? So, but that's, I tried that. And that's not correct. Let's take a look at their script. They have some evaluation script. Maybe that'll teach me something. Note also that our automatic evaluation tool. Let's see what they have. Tool, evaluation. Here we go. Comparison. We offer a set of evaluate absolute trajectory error. We align it using timestamps. Oh, are we not? Are these timestamps not at all matching the camera timestamps? Is that the problem? Because it's just sampled in a totally different, because I threw a lot of stuff away. I mean, it still doesn't explain everything, but... Oh yeah, these are just totally in the wrong time basis. Oh wait, these don't even line up at all. Oh, okay. Yeah, okay, fine. Oh, that's annoying. Okay, well... You see the problem? Like, these timestamps are just unrelated to... Ah, stupid. Stupid, stupid, stupid. It's stupid. That's dumb. That's wrong. Yeah, so if you guys saw on the other stream, I encoded these things in like videos so they were reasonable to work with. But that threw away the timing information. So they actually started the capture before they started the video. Ah, I got ya. Knew they were trying to scam me, bro. Trying to scam me. This free data set was trying to scam me. That's why we should have paid IBM for a data set. The data set we paid for... I'm not using Kitty, I'm using Freiberg. I'm sure if we had paid IBM for a data set, it would have been the highest quality data set ever. Okay. So let's write, that's not floats. Read lines X. Read lines sys.rq2. Read lines. Timing. Array lists. Map. No, we don't even need the map. Yeah, we do need a map. Then to x, x dot split that. Sub-zero. Float. Gotta get your parsings good, man. You learn this shit in CTFs real fast. Alright. Now let's see what's up. Okay, but now, welcome to another stupid thing where we're gonna run into a problem because you can't interpolate quaternions nicely. Oh, not a text. That, you know what that sounds like? That sounds like a Python 3 problem. No, that's right. That was my fault. Never mind. I'm sorry for blaming Python 3. Okay. So, we're going to want to do an NP interp now. One-dimensional linear interpolation. So, we don't want it to be one-dimensional. We want a multi-dimensional. SciPy interp. See the problem? Well, I was gonna play some Cardi B, but I'll totally get copyright strike for that. So we want to say GT sub 0, GT sub 1 colon. Is that gonna work? Probably not. I think it's gonna complain that it's like, well, you have to do it in order, otherwise it doesn't work. Yeah, object too deep for desired array, man. I'll show you a deep desired array. Deep interp. These are like helper functions we have at comma. Let's look at scipy interpolate. Maybe scipy interpolate has a deep interpolate. We got a deep interpolate. Oh wow, I could do. Oh, look at all these interpolators. Wow, and none of them probably do what I want because it's scipy. Oh, multivariate interpolation. Wow. Interpolate a 1D function. Like, this is bullshit. Interpolate over a 2D grid. But I don't want 2D. You guys know what I want to write, right? Like, I just want to broadcast it, you know? Oh, God, fine. GTT equals MP zeros. Timing.shape. Sub 0, comma 3 plus 4. For I in range 3 plus 4. GTT sub I, comma that thingy. I can just say I. Put I there. 1 plus I. GTT. Oh, they're not of the same length now, you're telling me. Oh, they're the same length. Oh, well, you know, we got to make sure they're that. That's very important to us. That's very important. Oh, great. Not broadcast array from... Yeah. How do I want to do this? I want to put a colon here. All right. Finally, we're in the right bullshit. Don't get the bullshit twisted, kids. If you get the bullshit twisted, you're going to have a bad time. Let's call this one GDT and this one GT. We can change that. Gonna have a bad time. Alright, we'll get rid of that stuff for now. Oh, well, index 3 is out of bounds with size 3. Oh, well, of course. Yeah, that makes a lot of sense. Perfect. Yeah, I love it. Yeah. Thank you. Oh, thank you for being so useful. Oh, well, let's just do 1 plus, and let's just say 1 plus, right? Yeah, we'll get rid of that 1 plus. Yeah, fuck you. Alright. Something. Okay. Now let's just try the first thing we tried, because that was probably the right thing. Wasn't the right thing. Maybe it was, and I'm just like going too hard. Look at the first 10 frames. No, it's not the right thing. Seemed kind of right, though. Let's try that. Not right. Is that right? Yeah, I know I'm trying things, but, like, at least, like, you know. Not right. Okay. Okay, why did I think this was better? Let me commit a little something. Let's commit a little something. I always feel better if I commit something. Alright, at least that's fixed. Now we can think more about other things. So probably what we want to do is we want to do that first. That's just if we rotate it back. And we ignore the... Subtract that. That moves it all on the y-axis, which I know is not right. Okay. So let's... Is my interpolation shit correct? We're reading that. Read in and interpolate to frame time. Videos ground truth. So we're in like 102. Down to 102. Why did I think this was better? It does seem to just move back on the Z. Like here, it just seems to move on the Z. Well, no, it's actually moving on the X as well. It's moving on the X as well. Well, yeah, I'm using NumPy interp. The problem is it only works on a one-dimensional function, not a two-dimensional function. Oh, there's plenty more work to do on twitchslam, of course, guys. Who said we're done? Never done. Well, so today what we're adding in is we're adding in basically ground truth. We want to see how twitchslam actually works. And we're going to write tests. And then we're going to stand up a Jenkins shit so we can actually run the tests a lot. I already wrote it. Okay, so look, we're moving along the z-axis, right? And you can see that right here. Like the movement along the z-axis is like 5 times larger than the movement along any other axis. We have very small rotations, and it moves straight on the z-axis up to like frame 40. So we should know that all the way to 40. Let's say left now. I mean, it's obviously correct. Like you can see it. But this is saying that it's moving equally as much on the x-axis as the z-axis. So that's not right. But that's because we're still in the rotation frame of the... I don't understand. I don't know whether they applied the rotation first or the translation first. So probably what we're going to want to do is we're going to want to... Maybe we do have to do the apply and unapply thing. All right. All right. what you think about remove print from terminal. Print use a lot of resource. Oh, well, when you put it like that, we should ban print everywhere. Especially in the media. Ban the media. No! Oh, this is wrong. Bro. Order of translation and relation for matrix interpolation. Bro. All right. Well, let's check to make sure we didn't do anything stupid, first of all. Let's print GT. This should be just the... Yeah, it seems pretty right. So these are the translation ones. You know what I hate? I hate when NumPy prints with that kind of shit. So let's just do, it's like numpy.set print options suppress equals true. Then it won't print in floating point bullshit anymore. It'll print in like human readable. No. Wait, what? Something else setting not suppress equals true? No, but see, like, I don't want it in floating point notation. Oh, maybe it just can't because some of them are too big. Yeah, okay, that's better. We'll put that up here anyway. It's a useful thing to have. Okay. So this is the translation. These are the quaternions for rotation. Now, there's a little bit of bullshit, but I don't think it matters. Well, we should really renormalize our quaternion. So we can do this here. Print np.linealge.norm. I'm still not opposed to that quaternion thing being broken either. But yeah, so when you do an interpolate on a quaternion, you have to renormalize it because the sum of a quaternion has to be 1. So let's just say GT sub 4 colon divided by equals, divide by the norm, is that right? You can print it to confirm. Bro, I give 0 shits about Google reCAPTCHA. Some people really don't know what a joke is. Whoever followed that and liked that thing really like missed the joke. Okay. Now my quaternion's normalized. I don't know. It's possible that this doesn't work. I did check to make sure they were valid rotation matrices by doing an SVD on them. Try that again. GTR is fine. Okay, fine. Yes, see, now it's not a valid rotation matrix. You can see these eigenvalues, or whatever these things are. Whatever the middle of SVD is not 1s. So you do need that. So now they're 1s. And now I'm happy. Okay, still not having luck here. Here's the thing. Here's the position. So the rotation, as it translates, it's definitely going to rotate. So there is a right way to do this, and we just need to think. Yeah, I did my pull requests. You missed. You weren't here for pull request hour. You know what I could use? I could use a piece of paper. That would certainly help a bro out. Paper. Okay, I mean, I think we want to apply the rotation first. Right? Like, here we are. Let's apply the rotations to the rotations. So now, yeah, we've applied the rotations to the rotations. So we've rotated the whole, like, okay, so here's the capture device. Here's this, and we've rotated it all like woo, right? And that's like woo, great. But now each one of those rotations is like we've pointed the first thing correctly. Now after we do that, we can subtract out the translation too. And now we've moved that. No, we can't. We can't because the rotation, I believe, still depends on the translation, right? Apply the rotations to the quaternary rotations. Yeah, we need a board. Okay, so now we've applied the rotations to themselves. I don't know if we can subtract. I still don't think we can subtract out the. Like, this is probably a really obvious thing if I just like could think a little bit better. We've applied the rotations to that. Now we're gonna have to. I think we definitely want to apply the rotations. Do we? I don't know. Subtract. Yeah, let's draw a picture in a paint program. Okay. Online paint program. Oh. Okay, let's try. Try online. No! This is so hard. Oh, I need Flash plugin. Oh, what? JS Paint that. Dead? What is this crap? Google sucks. Okay. Fine. So, here's the capture device. And here's a frame, and here's a frame. Okay, so the rotation and the translation are with respect to the capture device frame. So this is pretty good. We have iPaint, an online painting program. It's like MS Paint, which is exactly what I wanted. Cool. So we have to think about how to get this to be in the coordinate frame of the first camera. So this is the coordinate frame we're in. Maybe this with like an arrow pointing this way. And we have to get to this coordinate frame. So you see how like translation and rotation are intertwined right now. Let's think about what we have to do. I am rich, that's true. But I don't have paper because it's old. And we'll draw another frame over here. Right, I'm gonna have that frame there. 1 frame, 2 frame, 3 frame. Like, okay. You see why the first thing, we don't really want to rotate the world as the first thing. Yeah, I know. We don't really want to rotate the world as the first thing, because rotating the world will just rotate you around this center. Let's think, if we move the center from here to here, does that matter? Like, are the rotations still correct? This rotation's still going to be correct, but these rotations... Well, see, that's the thing. I don't really know, right? Which is applied first, the rotation or the translation? Does it tell me? Gives the position of the optical center of the color camera with respect to the world origin is defined by the as the motion capture system. Okay, so that seems pretty obvious to me. It's the rotation that's confusing. So it does seem like the first thing I do is subtract out the translation. Was that going to work? Man, it really depends on which is applied first. But no, that might be okay. So now that, if I subtract out the translation, can I get a new color? Does this have colors? No, I want colors. Are there colors over here? Oh, colors. Oh, perfect. Okay, so if I subtract out the translation, with my current understanding of it, it's just going to move. No! I don't even know how to delete this. It's going to move this to here. That's what subtracting out the translation should do. Right? Yeah, Bob Ross is the shit, bro. So if I subtract out the translation, it should just do that. And then, like, I don't really understand, right? Maybe I want to de-apply each rotation. Okay. We'll try de-applying the whole rotation. But that's clearly not right. Okay, so what I tried to do there was just de-apply this big rotation. But I don't think that's right. We can try de-applying the rotation from each translation. And that should disentangle. No. We don't have to do that. There should just be one rotation. It gets us back. No. Well, but see, that's weird. Because at least now all the movement is along one axis. It's just the y-axis. That just has like a fixed offset wrong. Subtract out the translation, de-apply the rotation from each translation. Do you actually mean that? Is that a serious suggestion? Here are the rotations. So they clearly change. Let's de-apply the rotations from the rotations. We'll start with that. So it's clearly rotating, which, I mean, it makes sense, right? It makes sense from the perspective of this thing is moving. But like, what doesn't make sense is why the translations aren't correct when I do this. That should make the translations correct. But it doesn't. They're wrong. Oh, wait. Gives the orientation of the optical center of the color camera with respect to world origin. Aha! So what that actually is this rotation is what it's giving me. So, whoops. Oh, come on. Can I have a blue? Can I have a blue, please? Can I have a blue? Yep. Oh, I gotta press OK. I see. And I see what you bros were saying. Okay, so that's that rotation. Gives the position of the optical center with respect to the world origin. Okay, so that's the position of the optical center with respect to the world origin. That rotation here tells me how to rotate that to look at that. But then I still don't understand why what I said was wrong, right? So if I just subtract out that and rotate them all based on the first one, that seems like it should be correct. I don't really understand it. I'll be back. I'm gonna pee. All right. All right, let's see. Okay, wrong. The orientation of the optical center with respect to world orientation. Transpose first. Okay, so inverse is the same thing as transpose for a rotation matrix. Then inverse. So you say I do that? Wrong. That's actually spookily the same. Which makes sense if I'm de-applying like one rotation, right? Position of the optical center of the color camera with respect to the world origin is defined by the motion capture system. The orientation of the optical center of the color camera in the form of a uniquaternion with respect to the world origin. But see, like, that's right. Oh. Oh, okay. Here's my theory now. So my theory is that this one is correct. But the axes just don't correspond. Yeah. Well, there's no reason the axes have to correspond, right? I wish they included like a little like picture to explain things, but I mean, if you think about it, right? We don't know what the motion capture system we don't know how the motion capture system defines the world. But otherwise, those look correct, right? Except for the fact that the axes are messed up. Like the motion capture system might define the world in some weird frame. Let's see which one that matches, because I think we can actually do this now. Yeah, so this is the one that's increasing a tiny bit. Oh, well, did that initialize backwards? Okay, that's right. There's a negative one. There's a negative one. There's a small negative one. Wait, does that like change a lot? Wow, it's like different for every initialization. That's the highest quality shit. Now there's like a small negative one, a slightly larger positive one, and a big positive one. So if I look here, there's a small negative one, there's a slightly larger positive one, and there's a... Okay. Yeah, you found our eval script? Let's take a look. Maybe they talk about it in here. Oh, hey, look, it's the exact same. So they're putting the translation in there. I don't know what they're doing. Oh my god, they have the ugliest interpolation you've ever seen. View the rotations along trajectory. Yeah, well, I mean, we can see what it is now, right? So the problem is just that these things are in the wrong order. So we have to also do a transposition. GTT equals GTT 120. Sorry, not 120. We want to first pick the small negative one, so it's 201. There we go. Those should match pretty closely now. High quality shit, guys. Okay. Well, so that's actually a rotation that we can apply. We can just talk about that rotation. Orient Python. It's like an orient library, I think, or is that just might be built into comma. So that rotation can actually be done. Okay, so if we have the y-axis and we want it to become the z-axis, we want the z-axis to become the x-axis. We got to do that. Oh, it's just annoying. But the reason we have to do it in a rotation matrix is so we can apply the same thing to the rotation. Right? So we want it to be this, we just want to do it with a rotation matrix. So I think the matrix, actually wait, I can define that matrix very easily. So if I want 2 to go where 0 is, just 1, 1, 0, 0, 0, 1, 1, 0, 0, 0, 1, 1. We'll call this camera frame from capture frame. Let's see if that's the same. Cool. That's the same. Alright, so effectively what I did is just define that as a matrix. And then we can apply that same matrix to the rotations. Well, that's at least ground truth for translation. Let's get ground truth for everything. So for the rotations, let's go back to our paint bro. rotation is going to be a little bit trickier. Oh wait, they just talk about the optical center with respect to the origin, so let's just unapply the first rotation. That actually might be all we need to do. I know we need to certainly apply this as well. Camera frame from capture frame. Well, that's not even right. You want to apply that first? Yeah, that's probably more right. Okay, cool. Well, put it this way. Let's do that first, and then we shouldn't need that, right? Undefined. Yeah, cool. So we'll just apply that to the rotation, and then we can de-apply the first rotation. We have to de-apply it after we apply it to the translation. Well, if that's the case, let's go back to even making this simpler, and let's try this thing again. So ideally, I would like to do it like this. No, that's not right. So we'll just keep doing this. Whoops. Okay, looks pretty good. I don't actually know if the rotations are correct. Maybe we'll find out sooner rather than later when we actually try to put these things into SLAM. But sounds good. Let's try putting these poses in now. GT pose equals none. If GT pose, let's say GT pose sub I if none if GT pose is none else GT pose sub I. Process frame pose equals none. If pose is not none, f1.pose equals pose. Well, so we actually don't want to just do pose because that's in there wrong. Else np when ouch inv. Alright, because we have the ground truth pose, we gotta invert it. It's high quality shit. Now let's just multiply this by something. 20. Kind of wrong. 50 is like what Slam was finding. Broken. Well, so the thing is, if pose, then we won't do pose optimization anymore. I don't know why, like, okay, it just moves them back to there. Attack it for now to fix the pose. Well, you know what? Or we just turn off optimization. Okay. Well, this is where things go if you just trust the ground truth. Of course, everything becomes kind of bullshit, but my rotations might be wrong. But that's the ground truth of the data set. I don't know, are my rotations wrong? Or am I like, let's take a look and see. We actually are moving that way. That's good. So the translations are definitely correct. I just don't know about the rotations. I don't know why it works so poorly. Alright, well, you know what's cool? We can just put this here. Ground truth for pose. That stuff doesn't hurt. We can actually add in observations before we get a pose. Okay, so that keeps doing that. Probably because my rotations are wrong. Let's try the rotation data set. Let's see if we can get the rotations to be right. And then I'm going to go. I have about 20 minutes more with you guys. You know how this goes. Yeah, okay, so the rotations are just totally bogus. Cool. Well, that's good to know. Let's go back to trying to debug that. So we know the first thing that happens is a rotation in that direction. So this is CV2 Rodriguez function. Let's try that. We're kind of here. For iron range 20 print CV2 dot Rodriguez. So what CV2 Rodriguez does is it gotta spell it right. It's just gonna print out like the Euler angles. There's the spelling. Just prints out the Euler angles. So it's very hard to like see what a rotation matrix is. Of course, yes, of course, yes. No, I need my parentheses because this is Python 3. Like civilized people. All So those are clearly wrong. Like, we know what's happening, and we know how it's rotating, and it's not rotating like that. Okay. So let's get rid of this for now. So, okay, there stands an argument that we have to do that, because that's why I do the translation. That's not right. We know the first thing that happens is a rotation like this. I'll be back. So let's first confirm that there's actually no translation in this data set. Yeah, that's pretty much no translation. Is that? Are we multiplying it by 20? Where's the times? Oh, it's over there. Oh, that's actually some kind of translation. Which makes me think we could be wrong again. Which makes me think what we actually might want to do is apply each rotation. That is some translation too. Like, we didn't really think this through, we just kind of typed. This is so shitty. I don't really know how to debug this. I just know that well, that's actually right, but only because our optimizer is so powerful. Oh, I guess we're not setting GT posts. Yeah, like that's saying that it's translating, right? There's clear translation there, which is wrong. Okay. Let's look at this. I'm speaking of Mapbox Locate later today, by the way, if anyone's going to be there. So interesting. So they have a, they're registering a translation here. I think. Yeah, there's a translation here, and there shouldn't be, because there's no translation. No, wait, there's no translation here. Which doesn't make sense, because... Yeah, that's... Like, I don't know, is that translation? Is that an appreciable amount of translation? Do I have to unapply each rotation is the question. Do I have to unapply the rotations before I subtract out the origin? Tomorrow we're going to get paper, and we're going to try this with paper. Yeah, bros. Okay, that's like way more wrong. It's still saying there's translation. The old GeoHot is dead. Killed him. I don't want to do that. Maybe that's the problem. Well, look at that translation. There's translation. There shouldn't be translation. At least I don't think so. It sure looks like there's no translation. I don't get it. I mean, this is very clear about saying, with respect to the world origin is defined by the motion capture system. That's very clear. Alt-R, reverse I search, XYZ. Okay, let's put it back to the thing that we know works for that. So, unapply the capture to camera frame. Yeah, so that works for that. And the only thing we don't know is what we have to do for rotation. The thing is, almost anything will work for this one. Wait, no, they're all messed up. Wait, hang on. Not almost anything will work. So that's just completely wrong. It's completely wrong because we have to invert that. I mean, now there are like subtleties of incorrectness. Maybe we need to invert them. See, it's showing translation. And it's translation that I don't really believe. But the rotation is completely wrong. Notice how like rotation and translation are intertwined. This is wrong. Look at what the optimizer says it is. It puts them down here. Scale drift. Sworn enemy of monocular slam riders everywhere. No, but like the rotations are wrong, and that's why this is messing up. You see them? They're not right. Might have to, I really don't know if order matters on these things. Well, we definitely don't need to transpose these. Wrong. Yeah, well, you see why that one has to go first, right? You can tell it's really wrong with the rotation. Alright, guys. I gotta go to work. See clearly my rotations are wrong. We're gonna think this through later. This is at least right in the presence of small rotation. Let's just make sure that things work when I don't submit any ground truth. That is because I wrote shitty... What? Rotation and translation. Broken. But let's make sure the good example still works. Well, that's reversed, but that's an initialization bug. Cool. Alright guys, I'm going to commit this. Let's give a prize to anybody who can actually, if somebody can fix this, we'll give you a prize. I don't know what the prize will be, but you know me, I'll be back on streaming the same hours tomorrow. Because, like Logan Paul and Jake Paul say, it's every day, bro. I think it's every day, bro, is really a really inspirational thing. Like, you know, it's every day, bro. Like, it's inspirational, because it is every day, bro. Like, that's a really, yeah, great thing. All right, cool, guys. Let's commit, we'll call it broken-ass ground truth testing. Broken-ass ground truth testing, because matrix is hard. But yo, but can I explain the problem that I want fixed? Okay. So if you go in here, this is clearly not the right ground truth for this video. Look at how it says that the camera is rotating like an idiot, like that, right? So it's because the way I'm extracting the ground truth is wrong. It's because like I have my like order of my matrix multiplies wrong or something. So you can check out down here. It's one of these that's wrong. So that's what I want fixed. But yeah, good luck with that shit, guys. I am out. I will see y'all tomorrow, same time. Let's see what we have today. What song should we start with? Yeah, we're open sourcing the map data. We're open sourcing the maps. The reason I think that about FPGAs and GPUs is you're just not going to get that much of an improvement over GPUs, right? It's all about... Pause music for a minute. It's all about how many transistors you use, right? I'll look into why nobody can subscribe after this. But it's about how many transistors are used, and GPUs are already using like 80% of the transistors, so maybe you can get a 20% boost, but you're not going to get like a huge boost. People think like the transition from GPUs to ASICs is going to be similar to the transition from CPUs to GPUs, and that just isn't true. This isn't like mining. Like if you're doing like Bitcoin mining, yeah, you actually get huge advantages from doing it with sorry, because I'm tired. From switching to an ASIC. I just woke up. The inference is much faster, not really. I just joined the Twitch affiliate program. Oh, I don't want to be an affiliate. Oh, no, that's bullshit. I don't like being affiliated with shit. All right. So where were we? Well, I was thinking maybe we could apply this thing globally. Let's first try this. I was thinking today we'd try just applying shit to the pose matrix so that the whole thing is kind of like applied to it once. Instead of not GTR. Pose. Instead of applying it just to the rotation matrix, because I think my translation was correct. Okay, so whatever happened there, it really messes these up. You see what's going on? Oh, well, no, that's fine, I guess. So we're de-applying the pose. Okay, well that's wrong. Like the code to fix translation was actually correct. I was just rotating it by this. I don't need money. Too much money, man. You can Google the Learn Index paper. Yeah, I mean, it might make sense for Google because, like, maybe you can even get 2x, but you're not going to get 10x. Is all I'm saying. Like, it's not enough to overcome like code inertia, right? Because they're going to be harder to code for than GPUs. Found another quaternion matrix which had different values. Okay, so according to this was the translation shit that worked. Let's go back to XYZ. I could see it better there. I had some translation thing that actually worked. That's not right. I shouldn't even be printing anything right now. This was working. Yeah, so that's putting all the stuff on the z-axis. You can see it there. Oh, crew's raising money. Raising money is not an accomplishment. Raising money is a sign of your weakness. And they advertise it like it's a strength. When we raised money, I was ashamed, as you should be. It means that you haven't made your company profitable yet. Do better. Okay, so if you de-apply the rotation, which is basically just applying the rotation, then you get translation in the right sense. Let's look through this. We're thinking this morning. So I'm thinking, not talking that much while I think. Position of the optical sensor of the color camera with respect to the world origin is defined by the motion capture system. Give the orientation of the optical sensor of the color camera in the form of a uniquaternion with respect to the world origin. So, the translation was weird, and it's questionable whether I want to apply the rotation. The transformation matrix is different, might affect it. Yeah, I mean, Tesla should be ashamed of the money they raised, too. But I think Elon actually properly is ashamed. Alright, sorry, I'm reading this on this little monitor. Let's go over here. Okay, so that's the same. Yeah, this is the exact same logic. They just call it transform 4.4. But yeah, I have that same function. Oh, what? Is it different? Why is this different? Why do they put 2 there? Huh. Look, the numpire is different from mine. See? So weird. Like, look, the numbers are different. Let's try theirs. Everything else is the same. Are my quaternions just weird or wrong? Otherwise, it's the same. Different. Yeah, okay, cool. Well, that's interesting. Good find, bro. Yeah, now those are the correct thing. And I didn't have to do any weird camera from... Okay. Wow. Okay, that might have been my bug. Yeah, the values are different. Look, I don't know why they're... I don't know what quaternion I had. Oh, maybe because W is the last thing, and they usually put W as the first thing. Ah. I see. Yeah, why do they put W as the last? I think that's the distinction, right? Let's see if it's actually off by... Yeah, okay. So this old thing was assuming... Ah. Okay, there's a different ordering of the quaternion. You see the problem? Good find, bro. So it's that. not, which is probably a more sensible way to do it, right? Okay, cool. Found that bug. Nice job. Nice job. All right. So now we do it with the inverse, and now I think we can probably just do this. And this is probably just gonna work. Yeah, all right, bro. Nice job. All right, we found the bug. Cool. Quaternions were out of order, and now the most obvious thing is correct. See how that works. Well, that's crap, but we can like multiply this by like 50 or something, so we get more translation. Aha, they work now. Cool. Cool, bros. Yeah, bros. All right, works. Maybe this is less broken. It looks a lot better. It's still saying there's translation, but like maybe there actually is. Let's get rid of that times 50. Just make that like times 10 or something? I don't know. Let's get rid of the times altogether. Yeah. Cool. Seems a lot better. Cool. Okay, so we're not going to sensibly get the depth of anything. There you go. I mean, the camera it's drawing is just so massive. It's kind of wrong. Oh, did I like do something stupid? No, that's alright. Oh, the other thing I was thinking is we should probably write a ground truth post processor and like put it in a more reasonable format. You gotta come to my things. You know, the talks probably aren't online. I don't know, they're not that good. I just say the same bullshit. Alright, let's commit that. Good job. Boston, Mass is a bro. You do win a prize. I mean, you'd win a prize if you sent in a pull request. Fix the ground truth parsing bug. No, we still do Scopy sometimes, but now we do Twitchies. So you can come on and you can see my Twitchies. Be slow, so slow, big slow. Okay, let's just write, let's write this as a separate tool. Like that shouldn't really be part of the main tool. All of this ground truth reader. Parse ground truth. I shouldn't even put that in helpers, you know, to be honest. Something that's really used for, like, we just don't use quaternions, so it's not really a helper for SLAM. I shouldn't even put this here. See, like, now we just have this NPC thing. Not an archive in the file. Just MP save. Call an MPY. Okay, so we have like that NPC file. Why doesn't... How do I load this? ARR0? What a stupid name. Why does it have a stupid name? This will be safe. It's not possible for Python to know the names of the arrays. Oh. What is this? That? Second one? I can call it pose. Cool. Yeah, I don't give a shit about the past, bros. Forget the past. There is only the future. Precision. Do that. Pose is not a file in the archive. But what? I called it pose. I don't understand. ARR 0. But I didn't call it ARR 0. Oh, I know what I did. Didn't call it ARR 0. Why does it do that? I called it pose. It doesn't make sense. Arrays to save in the file. Arrays will be saved in the file with the keyword names. I don't get it. What did I do wrong? Keyword arguments. Arrays to save the file. Arrays will be saved in the file with the keyword names. And it has the name pose. I don't, what did I do? Oh, maybe like that? Okay, fine. Cool. Now if I don't pass that in, I should learn my Emacs command line. Okay, that's good. Cool. Refactor to parse ground shipping. If you're downloading my videos, you're violating my copyright. You know I care very deeply about intellectual property, and I'll sue all of you. Sue people. What a morning, man. What a morning. Welcome to Thursday. We got a date tonight. I'm kind of excited about that. That's kind of exciting. What else is exciting? That the ground truth works. This is so exciting. Okay, so we have a little problem with this the scale invariance issue. See the thing? that? Oh my god, what did it do? So I can put a scale factor in there, and I think that works. It didn't work. What? Oh, because I did 0. Okay, so now that's at a normal scale factor. Let's just try for a second not optimizing a pose at all. So we can turn that off in point map. And everywhere we add a frame, let's say suffix true, right? Then we won't actually move the frames. Segmentation fault. What? That's concerning. The optimizer can't run if I tell it it can't move the frames? What's seg faulting? Optimize ground truth for pose. Weird. I'll diss you back, bro. So why is this seg fault? Because someone tell me. Bullshit. So you're telling me I have to enable that optimize, or it doesn't work. Like, is that what's really happening? I don't think so. Well, you know, let's just straight up disable the optimizer and see what we get. This is just estimating the positions from... Notice how nice and smooth it is. Right? Like, this is the true camera motion. It's beautiful, smooth motion. Oh, I messed that up. Without the optimizer, right? But now it's not optimizing the points. And stupid points are appearing behind the camera. You don't need to have this archived. Stop archiving. The past doesn't matter. Okay, so I still don't understand why this seg faults. Shouldn't be called with fixed points. GDB? Oh, I don't have GDB. I have LLDB. Oh, I love LLDB. Oh, it's my favorite debugger. Wait, yeah, it doesn't even work. Thanks. Thanks, LLDB. Oh, look, it doesn't crash on the debugger. Except it doesn't display the bullshit. Oh, because the optimizer is disabled. So threads like don't work, but that's okay. Okay, cool. What do we got? We got a null pointer in the optimizer. Why are we getting a null pointer? Where are we getting a null pointer? Is the optimizer running? Are we making it to that? Oh, no more that. No, segmentation fault 11. Is it crashing like, we'll get to here? And now it's gonna do me that shit about, oh, the last time. Oh yeah, don't reopen, great. Thanks. Thanks, Python. So we'll add the points. Oh man. So it does add the points. It just doesn't add the if I set them all fixed, it just crashes, right? That's so stupid. Notice how it looked a lot more smooth when they were fixed. It looks noticeably less smooth right now. Look at that frame. Why did that frame go there? Bad frame. Okay. Oh God, fine, good. Set fixed. Doesn't work. Set marginalized. I don't know what this does. The map points always need set marginalized to tremendously decrease the I don't know any of this shit, man. The bigger problem is, okay, so if I set these all to fixed, it just crashes. Like, how crappy is that? So crappy. Why? Why does it do that? Why can these not be fixed? No, that's a bug. Notice this likes to use that same weird quaternion thing where it does X, Y, Z, W. Interesting, right? That's right, the past doesn't matter. Markovian shit, bro. Let's just try something stupid. Wait. Maybe we can move around one stupid frame. Okay, if you even give it one frame to move, it's happy. It doesn't crash. But you can't give it no frames to move because then it crashes. Okay, so these are with the ground truth poses. So this isn't slam anymore. This is just because it's doing mapping, and I'm taking the poses from the ground truth. And my doesn't look that great, right? Like my has all this bullshit, so we got to get rid of it. This will give us an opportunity to tune the pruner stage. You see, look at all this. Like, that's not a real point. What is that? Get rid of it. All right, my I have to remember to actually change that back. You see the problem? I'm gonna forget. Okay, so less than 3-point match. That's old. I'm gonna get rid of it. Or MP mean error is greater than 5. Let's try like let's make this like 5. This is better. How many points are being called? Called 24 points. Are those like higher quality points? Not really. Like, my problem is, why is this crap still appearing? Does it go away? Maybe it goes away. What I'm basically saying is every point needs to have 5 matches now. And the error needs to be less than, I don't know, maybe that's actually just a really high error. Delete the point. Yeah, it does kind of look like a vaguely high error. Let's just do it if it's greater than 1. The reason he's failing is because he isn't taking the depth of the field of view. What? Why did Zeg fault? Oh, maybe we deleted all the things of the first frame. Oh, so it's not adding in my frame anymore. Oh, I see what's going on. All right. Open window equals none. And then let's just say old point. If length of p frames is 5 and p frames 1.id plus, I don't know, 10 must be detected more than half the frames is less than the map here, right? Map.max frame. Do I have map here? Obviously, because we're also making the points from, right? Self.max frame. Max frame, right? Yeah. So if ID plus 10 is less than, I'm just gonna say that. That sounds good. Alright, we'll make the point color much more aggressive. Oh, look, the map looks better-ish. Get rid of a lot of stuff. And now back to seg faulting. Great. Make that 3. Map looks better. Once in a while, you'll just get one where the points go everywhere, and it's kind of crap. Maybe I can fix this with an earlier filter. Try that. Crash. Why does it crash? Okay, now I'm only adding in points that have a lot more information. Like for something to be a new point, it has to have very high parallax. Still getting some of these crappy points. So these are ones that are just, they have bad feature detections. Alright, we have to figure out how to add back in that check. So if I want to bring things back to local, that should be right. So I dot it with the pose, which is stored as transformation from... Let's try that. So now we're not getting any of those points behind the camera anymore. I might have went too aggressive on this check. I like to do that. Alright, that looks like it's organizing into a better map. I'm just kind of going off of map quality here, but then like you get like that crap. It's not good, right? Like look at that. That isn't good. Look at all this. Why are all these points being added to the thing? Alright, should we read the orb slime paper? See what orb slime's culling rules are? Maybe we'll get inspired. Look at all this speckle. I want that gone. These aren't real points. These aren't really in the map. And they're making everything noisier for everybody. Okay. So let's put that back to that rule. See what we get. So now this is like optimizing the pose again. And now it's like crappy. Look, it's super crappy. Oh, look at that crappy. Oh, so crappy. And like puts it there. Yeah. And like moves it. That's so crappy. No, that won't use the ground truth. This is just optimizing. And look at shit. Look at that shit. TwitchSlam can be so much better. It's weird though, actually, when I let it optimize, it does a better job. Like the map looks better, right? That looks like a more solid map. Which is weird. Than when I put in the actual ground truth poses. I would assume that the ground truth's not wrong. I would assume that there's some other bug. Take the partial derivative of the points in 3 space. Bro, like you're saying words, but I really don't think that any of these make sense. The depth of the field of view. The surface of the high contrast point. Like, what is this shit? You know what, and so I do the velocity. I have a kinematic model. See my kinematic model? Very high quality. Did I write that right or did I write that wrong? I multiply the pose of the previous frame with the inverse of the pose from the frame 2 frames ago. And then I dot that velocity. That's pretty good. Like, the map looks better when I let it optimize pose, but, like, that kind of looks like crap. My filtering's probably not that good. All right, let's read the org slam paper. That's probably better. We can get rid of that added points print. Print spam. We should set local window back to 20. Just the window the optimizer can optimize over so it doesn't get really slow. Is this check correct? It's a good check to have. And then that scale thing. So I don't really know what to do about that. Yeah, kinematic model just assumes constant velocity. Let's do the org slam paper. I'm going to stop streaming a little early today. I should get to work early. Got work to do. Papers and sorted. Map initialization. Okay, we're doing okay about that. Features, local mapping. A representative orb descriptor D, which is the associated orb descriptor whose Hamming distance is minimum with respect to all other associated descriptors in the keyframes, which the point is observed. Oh, that's interesting. Okay, that's a cute way of doing it, right? Remember when we were talking about how to do the Hamming distance? So they just pick one that's representative. Maximum Dmax and minimum Dmin, which point can be observed according to scale and variance limits of orb features. That's interesting. Camera pose, which is a rigid body transformation that transforms from the world to the camera coordinate system. Camera intrinsics, all the orb features extracted in the frame. So it's really very similar. Velocity motion model, we're doing that. Oh, okay, well that's interesting. So they're using their velocity model and then using that for search by projection. They're doing their pose optimizer after search by projection. We can try that. Weird, it seems better. I don't know, like it's hard to quantify better. We should have it actually save the pose, then we can use the compare script. I don't know if it's better. But yeah, so that's interesting. They're talking about how they do their search by projection. It's weird. I was just because I had ground truth or no? Just messing up the first frame. No, that's the same pretty much. Alright, if tracking is lost, yeah, we don't have to worry about that. Track local map. Compute the map point projection X in the current frame. Discard if it lies outside the image frame. So actually that's exactly what we're doing here. Compute the angle between the current viewing ray and the map point mean viewing direction. We don't do that. Compute the distance from the map point to the camera center. Discard if it's out of the scale variance region of the map point. This is interesting. Compute the representative descriptor D of the map point with still unmatched orb features in the frame with the predicted scale and near access. So that's search by projection. The camera pose is finally optimized with all the map points found in the frame. So we're doing a pose optimization only with the points. We're doing it only with the points that are matched by the brute force matcher. Oh, here we go. They get into culling here. The tracking must find the point in at least 25% of the frames in which it's predicted to be visible. Wow, that's fancy. If more than one keyframe has passed from map point creation, it must be observed from at least 3 keyframes. Well, local bundle adjustment discards outlier observations. So that's exactly what we do here. Is my outlier discarder not good? There's bugs. There are bugs here. I don't know. Is 1 a lot of error? Is that a lot? I don't know. I don't think so. I mean, that's pixels, right? They KPUs are in pixel space. So it's a norm in pixel space. That doesn't sound like a lot of error. You can do that, but... Well, those look even better, actually. I'm really discarding a lot of crap. Unless crap shows up. It's not really helping. Like, it is discarding a lot of points now, but I don't know. I mean, maybe that's the wrong error metric as well, right? Because if your things are moving further, you'd expect the pixel to be higher. Oh great, it jumped to down there. Love it. Nice job, Slam. Why is it so noisy like that? Why is that frame there? Bad frame. Be more straight. Like, go with the other frames. Because when I run it with the ground truth, oh well, that has scale issues. Especially if I disable the optimizer. Look at them. Look at those beautiful frames. They're beautiful. That's what I want my frames to look like. But that velocity model works really well. I want my frames to look like that. So good looking. Well, yeah, I mean, I could add something to the optimizer to tell it not to do that, but, like, I shouldn't have to. Like, that noise is a result of noisy observations. I should just fix the observations. Let me read my matcher. Where's my matcher? Inliers. Wow, we really don't have a lot of inliers there. Like, look at all the inliers being discarded. It's a lot. It's a threshold I can change. Up my residual threshold, maybe? Like, just tons of shit's being discarded. Okay, there is a lot of noise there. But when I lower that, is more discarded? No, it looks pretty good. Over there. Is that better? Not really. Wow, that's what was making it slow, though. That's cool. You see the crap showing up here now? How fast it is, so fast now. We are triangulating, trust me. I'll just make things a little faster. That doesn't help. Be more like the poses. All right. Look at that high quality. I mean, I have no idea. Is that good quality or not? So I'm using that same XYZ data set. R1 XYZ, that's what I'm using, right? This is when you don't do any scale. It's impossible to see anything. And all the points show up way too close. Let's track a single point over time. Yeah. Maybe we'll do that tomorrow. Let's try it on Kitty. Let's try our best stuff on Kitty. No, we will lower this. We'll do max trials like 30 up the residual threshold a little. Speed. Bro, I'm not here to talk about comma. I'm here to talk about twitchslam. It's pretty good though. And pretty fast. Pretty happy with that. Like look at how much more straight it is here. I don't know why it's messed up on that other data set. It looks beautiful. Very fast. So these are getting rejected for some reason. I don't understand why. I worry that they're being rejected by that clause that I say might be broken. See how these aren't in the map? I know we've not added anything to the map for a while. Let's, yeah, it would actually be pretty easy to add more than one camera. There's nothing in here that assumes one camera. Let's figure out if that check's actually wrong. You saw how points weren't getting added past a certain point. Like once we got a bit more around this bend. Yeah, like if they have black dots like that, it means they're not being added to the map for some reason. That all looks good. Humans vaguely generate depth to eyes. You vastly overestimate how much that matters. No, but look, they're not being added to the map again. Look at these points. They're not being added to the map. Why? Why are there no points here? Those are good matches. I don't understand. Which check is rejecting them? Okay, so let's see what frame I'm at. Let's first see if it's a frame problem. So what if I do seek equals 200? Does that work? I feel like it didn't work. Huh, now I added them. When I run the whole thing, they stop getting added past a certain point. Even without that check, so I don't think that check is wrong. Could this check be wrong? Or could my triangulator just really not like things once the poses get large? I mean, that's a possibility. We can pretty easily just keep it local. Just effectively what it's doing. Yeah, see, look, these aren't getting added anymore. All those points are crap. Okay, let's try this. Empty dot f1 dot pose. Let's say L pose equals np dot f1 pose np acknowledge in the f2 dot pose. L pose here. We'll put np.i4 here. We'll call this points local. Now we want to say points 4D equals np dot email change f1 dot pose. That's not right because that's actually putting them in. Let's do that. Wait, is that more correct? Well, that's clearly wrong. But yeah, I mean, the question is, should we triangulate them in a local? We can triangulate them in a local coordinate frame, right? Instead of trying it in the global coordinate frame, because that could be the cause of these issues. The only point I have against this is I don't feel that OrbSlam does it this way. I feel like I've read the OrbSlam code and it doesn't do it this way. But otherwise, I really have no explanation for why they should be different. Okay, let's think this through a little bit more. Let's just try this. Let's put this here. And for this one, let's solve for RT here, basically. So we're going to just say f1.pose .np Linnell f2. No. God, it's so hard. One.pose. That isn't right. I don't give a shit, man. I don't know why I stream. I stream so I have someone to talk to while I do this. Oh, chess.com. You won't find me, though. Not that good. It's not inspiring. Fuck you. Nothing. This is fucking bullshit, man. I hate inspiring shit. Inspire people to do what? Just go do things. If you want to do things, do things. You don't need to be inspired. I don't care. What would I do with money? I can't buy a better laptop. They don't have one yet. Can't buy faster internet. I mean, yeah, maybe it's like extremely high thing, but then I have to like deal with the guy digging up my street for fiber, and my neighbors wouldn't like me, and then I gotta just deal with things, right? And that's a lot of effort. You ever deal with things? It's a lot of effort. So it's just something to do. Something to do every day before work, you know? So let me tell you, you know what my job is, guys? I just manage people. Like, I don't code at work. I manage. It's terrible. But here I get the program. I get the program in the peace and quiet of my lovely room while drinking yerba mates. It's just a nice, relaxing way to start the morning. I don't know. Today wasn't very relaxing, though. I don't know why. I feel like this is what I just wrote. I still don't exactly understand why it doesn't work. But okay, so I take the F1 pose and I remove the F2 pose, and then I'm left with NPI4. Alright, and then I have local points, and I can do that check. And then... I know, my code is shit. I know. I'll do better. Points 4D. And basically, I think I just want to apply F2 pose, because that's what he took out, right? this check back. That's right, isn't it? Is that right? Oh, cool. I did it right. So let's see if the problem still happens. Oh, the points are in the wrong place. Wow, I don't know how this works at all. It's putting all the points over there. That's just because I did something backwards. P-Algin. Oh, maybe. Maybe. Oh, was that better? Oh, that's better. Oh, that's good. If at first you don't succeed, like, invert one of the matrices and maybe they'll fix it. Well, let's see if the points turn black again. Or if they stay a good color. So we go around this turn. Like, now these numbers are getting big, right? I think it might just be like numerical instability of the DLT. I swear Orb Slam does it the other way. Like, I've read the code. No, this fixes it. Okay, fine. Who am I to argue with what works? Looks great. Look at that beautiful map. Oh, I love that map. So nice. Go back. Okay, good. It's still finding points. Looks good. Cool, we fixed it. Do triangulation in local frame. Cool. I don't know why that exits. Like, and that one doesn't exit. It's weird. I don't know. Use different sizes and colors for quaternions. Ranked by trustworthiness. You are an untrustworthy quaternion. It's pretty good. Hire you. Are you good? Do you know things? I'll tell you, the interviews for comma are basically, I sit you down and I ask you questions and know things. And then if you don't know things, I mean, that's okay to not know things the first time. And then I'll, like, tell you something. And then when I bring it up again 10 minutes later, like, no. Like, did you learn? You fixed my buggy code, man. Submit a pull request. I don't know. I fixed the bug, man. What bug are you talking about? This doesn't look buggy anymore. I mean, there's improvements that can be made, but I don't think there's bugs. I'm sure there's, like, subtle bugs, but, like, there's not major bugs. That's pretty good. Alright. Should we try it on Ohio? Let's try it on Ohio. Ohio's always a great test. Oh. Well, that's not right. It doesn't go that way. It goes the other way. Stop it. Bad Ohio. That's better. Yeah, wrong initialization is a common problem in Binocular Slam. Oh, yeah, map Ohio, bro. No, I don't care how old you are. No one gets any special treatment. I don't care. No, I came from difficult circumstances. Oh, I'm young. Oh, I'm a dog. Oh, you know, I don't care if you're a dog, but can you program? That's what matters. Do you know things? is the best I've ever seen Ohio work. What quaternions in the signs, bro? You're kind of amusing. I don't see any quaternions on the signs. That's a pretty good map of Ohio if I've ever seen one. I found this video on YouTube. It's a video of some guy driving to Ohio. It looks pretty good to me. Let's let it map Ohio for a bit more. Would I hire me at 17? Yeah, I probably would. He's pretty good. I mean, I wouldn't let him, like, code things, but I was good at hardware. I was really good at hardware. This is quality shit. This is the best map of Ohio I've ever seen. Just putting that out there. This is a pretty good Ohio map. Remember when we were at that Burger King? Look, the Burger King sign's right there. Right there. It says, like, Whopper. Eat Whopper. What are the green circles called? They're called orb features. They're not quaternions, bro. It only gets a little slower. Let's, switch triangulation to local frame. Look at that, look at that. This is a sick map of Ohio. Can you map in real time? It's not like that far from real time. This one's a little slow now. I don't know why it's slow. I'm gonna look. Let's see why it's slow. It's like not adding new points many. I don't know. I really don't know why it's slow. Yeah, it's a little slow. My friend's telling me about Flame. You know what we'll do? Tomorrow we'll profile. Tomorrow we'll focus entirely on speed. How about that? Does that sound good? Tomorrow. That's my promise to you guys. Well, no. Well, we'll see what time I get home tonight. But I will try to do that tomorrow. Reconstruct surfaces from the points. I don't know what you mean by that. I have set local window, right? Not that. Point map. Local window equals 20. Look at those signs. Like you can see them right there. Oh, beautiful. Look at them traffic lights. Look, you see them right there on the map. This is map of Ohio. This is nice. Like, now we know where Ohio is. This is a great slam. So tomorrow we'll work on speed. And then the day after that, we'll make the visualizer better. We'll actually have it, like, take some texture from the image and stuff instead of just a point color. But yeah. We're gonna make a turn? A turn would be cool. I don't know. Maybe that's not something people in Ohio do. I was there like once. I hadn't seen many people make turns. And you guys know there's only forwards too. Slam works better when you run it backwards. I'm not reconstructing surfaces. Oh, that's so annoying. There's no texture on the road. I'm not writing. This is feature slam. It's not dense slam. I mean, maybe we can start to add some, like, maybe we can start to make it more dense. But I think we gotta focus on speed first. Let's figure out why it's slow. Like, why is it slow right now? I don't know. It's because, it's probably because it's trying to, I know why it's slow. It's because it's searching by projection things that are behind it. Yeah. Search by projection less stupidly. Right? Because we're actually searching by projection. We're searching every frame. We're searching every point in the map to see if that's visible from my frame. And you don't have to do that. You don't have to do that at all. Okay, so we can search by projection less stupidly. That's going to give us speed. Because like it's fast at first, and then it just gets slow. Okay, so we will profile with flame. Search by projection less stupidly, because I think all the time right now, yeah, it is being spent on the search by projection. I don't know why this optimizer has all this error still. It was a big map of Ohio. Do you guys remember how this used to work? Do you remember how bad it used to be? Oh, this is brutal. This is brutally slow. It's like, wow. It's like a second a frame. It's even pose. Maybe we can, yeah. Don't add all points to the graph. Optimization graph. For pose at least. Yeah, so we don't have to add all the points to the optimization graph for pose because like the pose optimizer is taking time. Well, yeah, I mean, so we can look into OrbSlam is doing this like clever thing where they like keep track of like which frames are likely the points to be found in. We can do the same thing. Oh, good. Look how it's rejecting those points. So good. Wow, that's a lot of features on that cinema. Look at that search by projection quality though. You can't do that with Orb. You need to search by projection. The bottom of that cinema. Okay, so it can scale better with that. Downsample orb points that are super close together. I already do that. I don't think you want to make the map less dense. I don't think we want to do that. Like I don't think that's the problem. We're not getting that many matches. I'm not actually printing out the number of matches we're getting. Some of these might just be a lot of matches. But yeah, I mean, I think the problem is just that we're look at that cinema. Use a higher resolution video. Is a good drive through New York. What's the license on this? It's long. Hey, I'm happy to try a different video, but there's a few things that it can't have. So this might have cuts. We can't have cuts. It has to be Creative Commons licensed, and it has to be relatively short. Or maybe this doesn't have cuts. Oh man, but like this is a busy environment with a lot of moving objects too, which is going to make it hard. George Hotz doesn't do shit. He's dead. My name is Tom Cruise. I code SLAM on the internet. And then I want to push on the density of this SLAM. Right? Like I want it to, after we get this to work, what I really want to happen is I want this to do like dense surface. Oh, look at all those points of infinity. We don't do a good job of points of infinity right now. I want to do like dense surface reconstruction. So it's like a super dense SLAM. What's the license on it? Is it long enough? It's too long. Find me like a 2-minute Creative Commons license video, and we can try it right now. We're gonna work at 10 today. I shower still too. Oh, yo, let's listen to Sell Out by Real Big Fish. Yeah. No, I don't want to watch the music video. Let's listen to it on Spotify. It's a great song. Should you do this one? There's too much motion. Come on, bear! I'm waiting for you. Let's see what we got. Creative Commons? Standard YouTube license. Creative Commons is better. Wait. Oh, I thought he was gonna sit in the chair. Oh, that's a letdown. Ooh, the Immortal Rook Lift. That looks really good to watch. I thought the bear was gonna sit in the chair, okay? I'm let down. Alright, this looks pretty good. No. I'm embarrassed how bad I am. Oh, my media. Oh, that's a lofty way to describe what that is. Media. No, you guys are bad at chess. Well, I'm not patient enough to play like long time control games. I'm better at long time control games. I play 10-minute. All right. Oh, we got 44 people. All right, let's watch. Let's see if we can find a short NYC driving video. Short. 5 minutes of driving in New York City. Okay, and it's a. Oh, I love that fake news too. Look at that. It's not 5 minutes. All right, so that guy. Yep, just that was a red light. I'm sure. Yep, good job, bro. Can I watch this at higher speed? This was a good video. Well, that guy. Yep, yeah, good, nice U-turn, bro. All right, well, it's gonna detect all the features on that shit. And then this gets like sped up weirdly. Okay. So good. These are good things for a slam to detect. All right, this one looks good. This is too long. It's gonna take too long. We'll try this one video and then we're out. Download. One moment, please. All right, we're going with the dual pronged attack here. Wow, that's a long video. Damn, you got stuck in a lot of traffic, bro. That's good. What? Don't do speedy. Did YouTube like break this stuff? Oh, convert IO. Oh, okay. Is this one gonna work? This is terrible. This is not Creative Commons? Yeah, it is. Select video quality. Yeah, come on, bro. Oh, my Adobe Flash is out of date. Oh, that's great. Oh, thanks. Oh, starting conversion. Oh, that's high quality. Start. Yeah, 0. Oh, look, this is exciting. Use that. Oh, that's nice. That's a GitHub download. I trust that more. I think that's hosted on GitHub. I trust. Wait, what is this shit? Oh, it runs on my computer? Oh, that's sketch. Oh, yeah. No, we got this. Yeah, 100%. 100%, bro. Look, my Ohio map is still being made. So good. Failed? Oh my god. Oh, now, yep, Flash, okay. Is this a scam? It's just a scam. Fuck. This is terrible. Now I don't even know where my URL went. 5 minutes of... Alright. Is this gonna work? We are not authorized. SaveVideo.com. Should I just get YouTube DL? Wait, what? Okay. Alright, what is this YouTube DL thing? Let's see. Alright, whatever. sure it's not that sketchy. Oh, the ad. I'm not turning off my ad blocker. I'll just install this. All right, let's go. Yep. Okay, cool. So what is it? YouTube DL, and I paste in the video name. Oh, sorry. Wow. Okay, that was bad. I alt-controlled my... I'm tired this morning. I live in a closet. Oh, this looks high quality. Oh, yeah. Oh, YouTube DL. You bros know what up. All right. YouTube DL bros coming through. All right. Why did it... Videos. I call the videos test. Oh, whatever. Test NYC. Okay. So our beautiful map of Ohio is still being made. We are going to Control-C this. And let's try on NYC. Brand new video. Oh, look at the quality. Oh, look at that quality. Oh, look at that building. My focal length is clearly wrong. My focal length is wrong, that's why. Oh, damn. Pretty good, right? I like this video because it has a turn. YouTube DL. We're going to be using that in the future. And NYC and update readme. Let's see. All right, let's make that turn. Let's go turn, bro. Look at all these features. Getting a lot of features. This is a pretty nice map. I mean, no, actually, it looks massively skewed. I think my focal length is wrong. Oh, no. Look what it is. Oh, look at the barrel distortion on the website. I mean, on the camera, look at the barrel. Barrel distortion, bros. Can't have that. Let's see if it's going to work on the turn. Will it work on the turn? I don't know. TwitchSlam's never really been tested on turns before. He does make a turn here, right? Oh, this is too slow. This is egregiously slow. Tomorrow. Speed, guys. I know I'm getting orbs on the text, but it's good. It's rejecting them. Or it's staying there at infinity, which, I mean, it's kind of stupid, and it's going to be annoying if we try to get rotation. No, actually, they're black, so it means they're not being used. Good Twitch Slam. Good Twitch Slam. Alright, come on, turn. Who's excited for the turn? Are you going to turn here? I thought it turns here. Alright, well, that's the guy who runs through the green light. Yeah, it only uses one core. I know. The GPU. I mean, we can try using the GPU. Tomorrow we'll profile and figure out what's slow. We'll figure out a breakdown of the time. And we'll think about using the GPU. I don't know what we're going to use the GPU for. Like, is it the optimizer that's slow? It's probably just all like the Python-y crap. Yeah, I know, I'm sorry. I'm sorry, you guys, I'm poor. Donate to my Twitch stream so I could buy a new computer. Twitch Slam hype, come on, make it turn. It's gonna turn, bros. You think the turn's gonna work? Yeah, I give it a good 30% chance of working. Yeah, it's gonna be good. Alright, you see how we slowed down? You see how like there was a lot of speed there and then we slow down? Now it's slow and now all the frames are really dense. So we're not using... OrbSlam uses keyframes. We're not using the keyframing strategy. We're actually just putting every frame in there. Which I kind of like. I don't really like the idea of keyframes because then your thing's not like optimized perfectly. I'm sure OrbSlam has good reasons for keyframes, but I don't really like them. Oh, look. Is that turning? Is that turning? What up? I think it's turning. Oh my god, this is horrendously slow. Yeah, it could be a Twitch thought? It could be a Twitch thought. Smash that up button. Yeah, hit that subscribe. You can't even subscribe. I don't know why you can't subscribe, but apparently you can't. Because I didn't like sign up to be a Twitch affiliate or whatever. I don't know, man. The world is full of scam. I mean, it just seems so scammy, like a Twitch affiliate. It's still funny. I agree with that. I'd be a Twitch dot. I'm gonna be a Twitch dot. What do? I should watch some Twitch dot teams and do what they do and see if it works for me. And then when it doesn't work for me, I'll scream about sexism. That always works. It's turning. It's turning at a very slow... Oh my god. Okay, that was the worst turn I've ever seen. Well, I think it's a few things. I think my focal is wrong. I mean, that was a 90-degree turn, and TwitchSlam turned a whole 20 degrees. Put my leg on my chair. I'm not... Do I look like any of those people, man? I don't know why you think I'm anything like those people. Bill Gates, Steve Jobs, Steve Wozniak. I'm just not like those people, man. I don't know who that is. Maybe I'm like that guy. Well, okay, like it kind of made a turn. All right, we'll call that. You know what? This is undebuggable until we make TwitchSlam fast. I know. It's horrendous. All right, guys, today we fixed bugs. Tomorrow we make speed. What do you think? Look, it made a good map until it made a turn. Oh, it was so good until it turned. I need to learn from the best streamers. What is this? Is this PewDiePie link? I love PewDiePie, man. Oh yeah, who's this? Twitch trending. Am I gonna get a copyright strike for this? She's pretty.
We're gonna play a game of League because I promised Daniel I would.
Can I buy things off her wish list?
Even though I'm not a League player, guys. Oh my god.
No, that's not my date.
Oh my gosh, it exploded everywhere!
I really don't think I would not get along with this girl.
No.
Don't click on every link you see. I love clicking links, bros.
Oh no!
Oh no.
Hold coal, okay. Hold coal, step one.
Wow. It's a nice chair. Alright, now I'm over this. Alright. No, I closed out the chat, guys. I closed out the chat. I Mac key queued. So sorry about that Mac key queue, but I think that means that I am out for the day. That's it. That's today's stream. Tomorrow we'll make things fast. Bye-bye, Twitchies.